in the background.
Yeah.
Live streaming.
All right, so this is welcome to the Baton Rouge Astronomical Society meeting for the month of August, I think it is. I don't know. I'm starting to lose track of months here in the summer. It's particularly hard. Our guest speaker for tonight is local television personality and weatherman Steve Caparptta, who is here to speak with us about hurricanes. And we're very glad to have him here, especially since they've just now announced that we're expecting even more storms than we normally get for this time of year. And seeing how it's been a good long while since we've actually taken one to the face, he might be able to assuage some of our worries about what's coming up in the next couple of months here, hopefully. If not, then he'll give us sufficient angst over against what we already have, and we can then thus prepare ourselves for the future. So with my great appreciation, I'm going to hand it over to Dr. Caparptta here and let him begin his presentation.
All right, Scott, thank you very much. First off, I'm going casual tonight. Hope everybody's good with that. And secondly, if you're wondering what's back behind me, I'm actually in my girls. I've got two daughters. I'm in their playroom tonight. That happens to be the quietest room in the house up above our garage. So if you catch some little girl tents and some girl looking things behind me, that's why you see it tonight. But really appreciate the opportunity to be here. I'm gonna go ahead and share my screen now so that hopefully you guys can see. Hang on a second. Now it's not giving me the option. Let's try this again. Get my screen up here. There we go. All right. Can everybody see it now?
Yep. I got you.
All right, good deal. So Coy invited me out, and he'd asked me if I could possibly speak on something kind of related to astronomy, and my short and simple answer was not really. But he did mention, that you guys might be interested in hearing a little bit on the Coriolis Force. So I'm going to briefly hit on that, but then I'm going to get a little more into number one, some of the forecasts for the season, and then just kind of a brief historical look at what we've been through here in Louisiana. Quickly about myself, got a bachelor's degree from meteorology, University of South Alabama back in 1998. Never really had an intention to work in TV, but here I am 20 plus years later doing it. I started out in Lake Charles, spent a couple of years there, a couple of years in Columbia, South Carolina, and then I've been at WAFB in Baton Rouge since 2003. While since here in Baton Rouge, I went ahead and got my master's degree, and my PhD at LSU falls under the Department of Geography. But my coursework and the research I did was all weather and climate related. That gets a little confusing for people sometimes. So to start out, since Coy asked me to talk maybe a little bit about the Coriolis Force, I know this is kind of like a kitty looking graphic, but I was just trying to look for a couple of GIFs that kind of showed it. So in the Northern Hemisphere, we know that the Coriolis Force essentially gives us this effect where everything appears to be deflected to the right when in motion. And that's what that's showing. And then if we go to the Southern Hemisphere, everything has this apparent drift to the left. Now, we'll talk about, the Coriolis Force gets stronger the farther you get from the equator, and I think that's even what they're kind of trying to show a little bit on that particular graphic. But as it relates to hurricanes, you're probably aware hurricanes an area of low pressure, right? So in low pressure, the winds converge toward the center. The winds blow inward toward the center. Now, if we didn't have this Coriolis force, which is the result of the Earth spinning on its axis and the fact that the Earth is spinning much faster at the equator than it is at the poles, we wouldn't get this deflection. But in the Northern Hemisphere, as those winds try to come together from all directions, we get this deflection to the right, and that gives us, within our tropical storms and hurricanes, the counterclockwise motion. In the Southern Hemisphere, since the deflection is left of the flow, their tropical systems spin clockwise. So that's why we have this difference on either side of the equator. Now, I don't want to get too deep into math. I know nobody probably wants to get deep into that, but here's where it gets interesting. When you look at the equation for the Coriolis force, the last variable in there, A, is for latitude. And then if you think back to your trigonometry days, if you can remember any of that, the sign of 0 is always 0. So if we consider the equator, where latitude is 0, that means Coriolis, you do this equation real simply, the Coriolis force is going to be 0. So that's important when we look at our tropical system. So this particular graphic is the shows all the tropical cyclone tracks from 1980 through 2018, all the different basins that we track around the globe. So you get the Western Pacific, the Eastern Pacific, what we call the North Atlantic, the area we're most interested in. But we also get tropical cyclones down here in the Southern Hemisphere. But if you look closely at this map, one thing that you might be able to pick up pretty easily is that within about 5 degrees either side of the equator, we don't have any of these tracks. And so that's why the Coriolis, where it really comes into play with our tropical systems. Since the Coriolis force is 0 at the equator and it only slowly increases as you get farther away from the equator, we can't really get that necessary spin to get a tropical system. But once you get 5 or so degrees, and typically it's closer to, as we track our systems in the Atlantic especially, it's really closer to about 10 degrees away from the equator before we really start seeing that spin. Now, some scientists have looked at this and they think theoretically, although nobody's been able to find an instance, they do think we could have a tropical system cross the equator, an existing one, because they think there would essentially be enough momentum where that would maintain itself if it was strong enough and well enough organized. But we can't really have one developing right along the equator because of that lack of a Coriolis force. So there you go, Coy, hit on that a little bit. So let's talk a little bit about what Scott was mentioning, the outlook for this season. So we know the long-term average in the Atlantic and the Gulf of Mexico is about 12 named storms, 6 hurricanes, 3 major hurricanes. Sure, most of you are aware, a major hurricane, that's a category 3, 4, or 5. So far, it's already been very active, as I'm sure you've seen too. We've already had 9 named storms, 2 hurricanes, but no majors yet. Not unusual given how early, but 9 named storms already. That's pretty unusual. Dr. Phil Klotzbach is one of the best-known hurricane forecasters. He actually studied under Dr. Bill Gray, who was the guy that really originated this stuff back in the 1980s. Just a couple of days ago, Dr. Klotzbach updated his outlook for the season, and he's now going with 24 named storms, 12 hurricanes, and 5 majors. Now, those numbers, his forecast does include the 9 named storms, the 2 hurricanes we've already had. But if you do a little quick math, he's saying another 15 named storms going forward, another 10 hurricanes, maybe another 5 major hurricanes. So that's a lot. NOAA, the National Oceanic and Atmospheric Administration, the parent agency of the National Weather Service, also updated their forecast the other day. And pretty similar. They give a range, but went with 19 to 25 named storms, 7 to 11 hurricanes, and 3 to 6 major hurricanes. They called it what they say what could end up being a hyperactive season. In fact, if we take Dr. Klotzbach's 24 named storms, for instance, that would be the second most on record, in records that go back to about 1850. So we're talking about some pretty big numbers. So just quickly, here's a look at what we had so far. The season got an early start. We had Arthur and Bertha. I believe both of those were in May. And just illustrating some of our shortcomings still in forecasting tropical systems. The day before Bertha formed, I think development chances were very low, maybe at like 20 or 30%. And then we woke up one morning and we basically had a tropical storm on the coast of South Carolina. I'm going to show you in a minute, forecasts have gotten a lot better with time, but as I'm sure you know, there's still room for improvement. Then we had the Louisiana landfall, kind of that strange storm, Cristobal. They came in near Grand Isle over New Orleans and hooked a left and passed just northeast of Baton Rouge. Didn't produce all that much locally. We got lucky. It was kind of lopsided to the east, so the impacts here were limited. Dolly out there in the North Atlantic, Edouard out in the Atlantic. Faye was a quick-hitting storm up in the northeast. Gonzalo formed in the Atlantic, died in the Caribbean. Hannah's was certainly a noteworthy one. Strengthened more than expected, came into South Texas, was strengthening right up until landfall, made landfall as a Category 1 hurricane. Had it had any more time over water, probably would have been stronger. And then finally, as I'm sure you remember, what was that, last week that we said goodbye to Isaias, which also produced some significant impacts because it impacted so much of the East Coast. We had millions that lost power, even though, if you want to call it only a Category 1, produced some significant impact. So bottom line is it's been very busy already. I just grabbed this little satellite loop out into the Atlantic. We are tracking something right now. It's right here. If you can see this tumbling motion to the clouds, this is where things get a little bit interesting. So you look at this, most of you probably aware when you see that counterclockwise spin that shows you low pressure. But what's pretty cool in this day and age is we have some satellites, some satellite products that can essentially give us a look underneath the clouds. And what they're saying right now is that while we see this twisting in the clouds closer to the surface of the ocean, the spin isn't very well organized yet. And that's important because this won't get an upgrade to a tropical depression or storm until you have a surface circulation that's better organized. The reason for that is we know these systems are real prone to they can die out real quick if they don't have a well-defined center of circulation that's down at the surface. So the National Hurricane Center does give it a 60% chance of developing. This is the box where they think it could happen. But also noteworthy is it looks like the next couple of days it has a chance, but as it gets farther west, it looks like there may be some dry air and some wind shear that come into play to where hopefully, even if it does develop, that may kind of knock it back down and it may not last that long. So we'll see. But that's the only one in the Atlantic we're kind of watching right now. The Eastern Pacific is much more active, and typically when you have the East Pacific pretty active, the Atlantic's going to be a little quieter. It's kind of a seesaw. So we'll keep an eye on that. Looks like the East Pacific may be active for another week or so, which may help us out a little bit. This is a look at the tropical storm and hurricane names that we use. It's just a couple of quick things, a little points of trivia I like to point out on this. So the ones that are kind of the gold shade, obviously, the names we've gone through, but I speak to kids a lot. And so the number one thing I tell them is the names, they go in alphabetical order. But if you do the math there, if you count real quick, there's 21 names. And how many letters in the alphabet? 26, right? So there's 5 letters every year that don't get used. Q, U, X, Y, and Z. They never get used. The organization that comes up with these names, I know some people have been kind of mad about some of the pronunciations, but it's actually the World Meteorological Organization, which is represented by countries all over the world. And they have 6 lists of names, and they get rotated. So the names that are used this year in 2020 will come up again in 2026. As one exception to that, if a storm does a lot of damage or if it ends up being a real deadly storm, they'll retire the name and they will replace it with something else. Now, one thing has come up a lot with the season already being so busy and with forecasts for it continuing to be busy is what happens if we go through all 21 of those names? Well, we then go on to the Greek alphabet. So, sorry, grabbing a sip of water there, but we would go on to names like alpha, beta, gamma. That only has happened one time before, and it's a year you probably remember. That's 2005, which was remarkably active. We ended up with 28 named storms in total, and that includes a very busy, what was a very busy year in the Gulf of Mexico, including here in Louisiana. I think it's the only time on record, I think, where we've had 3 hurricane landfalls in Louisiana in the same year. So a lot of you, everybody's going to remember Katrina. Just about everybody probably remembers Rita. So let me show you. Katrina is this red line. Rita is this red line. But there's a third hurricane I sometimes call the forgotten hurricane of 2005. And that was Cindy, this orange line. This one hit early July, came across Grand Isles, Category 1. Since it was relatively weaker compared to Katrina and Rita, which were such devastating storms, people often forget it, but it was a high impact storm. Now, one thing, while this year's been off to a very busy start, if we try to compare it to 2005, there are some big differences. 2005 already at this point in the season had major hurricanes and big impacts. We haven't quite seen that. If you can make this red line around Pensacola, that's Hurricane Dennis, right where it says 22, which is labeling a different system, but the red line is Dennis. That was a major hurricane. We had Emily. That was fairly early in the season. That was a major hurricane that came in northern Mexico. So we haven't, at least a little bit of good news, we haven't seen that level of activity yet this year. This is a graph I've kind of borrowed from Jay Grimes and I've kind of added to over the years. But I think it paints the story for us here in Louisiana about when we need to be prepared, most prepared, and when we get most of our hits. So what we're showing here is that about 45% of our tropical storm and hurricane impacts come in September. September is far and away our busiest month, then August. And then if you combine August and September together, about 2/3 of our tropical storm and hurricane impacts are in those 2 months. So we're just now starting to move into the heart of things, and it's really mid to late August where things typically often start to pick up. But the bad news is, I guess, guys, is that we still have the heart of the season. And even in October, we can have significant impacts. I didn't put a graphic up, but memorable storm for me in October. I grew up in the New Orleans area, was Hurricane Juan. It was actually at the end of the month, and it was a crazy storm. It did a couple of loops down along the Louisiana coast before it finally went across Grand Isle and headed over towards Mobile, but it impacted us for a while. I remember it best because I was out of school for about a week as it kind of danced along the coast. All right, so why we expect a busy season? This is a GIF, but this first graphic is showing sea surface temperatures in the Atlantic, way above normal. All right, this is wind shear, and I'll talk more about this in a second, but here's Africa. Here's the Yucatan. Here's the Caribbean. That blue is showing wind shear lower than normal. Sea level pressures, the blues, they're running well below normal in the Atlantic. And then this is rainfall over Africa, running at near record levels. There's something we call the African monsoon. That's important. So this will loop again, but look, the sea surface temperatures warm across just about all the Atlantic and near record levels in some spots. The wind shear bad for tropical systems. Well, it's running well below normal from Africa through the Caribbean. That's not something we want to see. Sea level pressures, low pressure makes it easier for the tropical systems to form. Very low relative to normal near Africa and across much of the Atlantic. And again, Africa just very wet, which tends to lead more of those systems developing. Another thing that would leads to this idea of a busy 2020 hurricane season is what could be a developing La Nina in the Pacific. So get your bearings here. This is South America. Here's Central America. Here's Mexico, and coastal Louisiana is right at the top edge of that map. But these are sea surface temperatures, and it's this nose of blue here off the west coast of South America and Chile, where the waters are running cooler than normal, and that's evidence of potentially a developing La Nina. So why does that matter? Why does what's happening over here in the Pacific matter for us in the Atlantic? Well, we know when we've got a La Nina over here, more storms form over here. And the main reason for that is that wind shear that tends to knock storms down. When La Nina is present, the wind shear tends to be lower than normal out here in the Atlantic. So that favors more development. And also, the cooler water in the Pacific over here tends to make the Pacific more stable. So I was telling you how the East Pacific and the Atlantic, it's kind of a seesaw. So that means when it's more stable over here in the East Pacific, tends to be more unstable over the Atlantic. So that's why La Nina is not something we like to see. It tends to lead to more storms in the Atlantic. Here's another look at the water temperatures. Now, these are sea surface temperature anomalies, so the departure from normal. And what you see here, this is the last 30 days. I pulled this over the weekend, a couple days ago. The bottom line is from the west coast of Africa all the way across the Atlantic through the Caribbean, and at least in the parts of the Gulf, water temperatures are running above normal and in areas well above normal, and even up along the east coast of the U.S. As we zoom into the Gulf, yellow to orange above normal, the gray is kind of close to normal, maybe a tiny bit below normal near the Louisiana coast. That doesn't matter. That's not going to have a big impact. Bottom line is that's a big reason for these forecasts for a very busy season. Water temperatures are running very warm. Now, here's something you may not have heard so much about. I'm going to step you through this quickly, but it's something I like to look at in hurricane season. It's called the loop current. So sometimes I think people focus a little too much on the sea surface temperatures, because the sea surface temperature, surface is the key word, really is just that, the temperature at the top of the water. It doesn't tell us anything about how deep the warm water is. Well, we know there's something called the loop current. So you've all heard of the Gulf Stream, which runs up east of Florida and up the East Coast. What's a lot less well known is the loop current, which kind of comes through the Western Caribbean, around the western tip of Cuba, through the Florida Straits, and it eventually links up with the Gulf Stream. Why it's important on a map like this, what we're looking at, this is actually sea surface heights, but in simple terms, the areas of red are not only warm water, they're very deep warm water. Sometimes you can have in these areas like this where I'm highlighting, we say that for tropical systems, the water roughly needs to be about 80 degrees. Well, that 80-degree water can extend hundreds of feet down below the surface. And that's real important because as a hurricane comes across, got a lot of wind with it, right? That stirs up the ocean. And sometimes what that'll do is it'll pull up some cooler water from below. And that's a negative feedback mechanism on the storm. We call it upwelling. Well, if that warm water is real deep, it's like an endless supply of fuel for the storm. Now, I'm going to show you a little animation I put together just to show you a couple other features. This animation started June 1st, the start of hurricane season. It runs through a couple of days ago. A couple of other interesting things that happen. So this is a warm eddy. They rotate clockwise. This thing, if I had an animation long enough, likely was part of the loop current. These warm eddies, time to time, they break off and they drift westward in the Gulf. They're important too because not only do the hurricanes sometimes track over the loop current, but sometimes if they track just right, it might go over one of these warm eddies and that'll give it a boost. But we do get cool eddies too. So they rotate counterclockwise. And that doesn't mean the water here is real cold. It just means that the warm water is not necessarily very deep. And so sometimes those can help kind of limit a storm from developing as much. Then the last thing I wanted you to note was at the beginning, note the loop current is kind of down around western Cuba. And then with time, it starts to bulge northward. Now, I'm not an oceanographer. I'm not an expert on this. I know some about the loop current. I know it fluctuates north and south with time. I don't know if the reason for that is well established, but it's something to watch. You know, if it keeps this trend of bulging farther northward into the Gulf here with time, that's not something we want to see. That just makes it easier for storms that may be coming across east to west to potentially track over this and feed off of it. For example, Hurricane Katrina. This is a similar type plot. The loop current, this is a bit of a warm eddy that was beginning to break off from the loop current. And then the black line here is the track of Hurricane Katrina. I'll show you a more zoomed in version. But the bottom line is Katrina tracked over the loop current and this eddy, if you will, for about a day and a half. So it tracked over this really deep, really warm water for a long time. And that's when it became a Category 5 hurricane. Now, having said that, for a hurricane to get strong and really intense, it's not just about the ocean and the water. The atmosphere has to be just right too. But we know with a storm like Katrina, the fact that it went over this loop current, this really deep, warm water, certainly contributed to it getting so strong. So that's an example why we watch it. When Hurricane Rita came across about a month later, it tracked a bit over the loop current. It came over this eddy for a while. So it also benefited from that deep, warm water. All right, let's talk a little bit about forecast accuracy with hurricanes. So in this graph, we're looking at the accuracy of forecast tracks, the tracks of the storms, different time periods. So you see the legend, 24 hours is red, the sort of orangish color is 72, and then the blue is 5 days, 120 hours, 5 days. The important thing to note on this graph is the slope. Everything slopes down toward the right. That tells us errors are decreasing with time. Forecast tracks are getting much better as time goes by. For example, our 5-day hurricane forecast today are more accurate than the 3-day forecast was just 20 years ago. So the forecasts are getting better and getting better pretty quickly. It's a little bit of a different story when we look at the forecast intensity of tropical storms and hurricanes. You notice there's a bit of a slope down to the right, but it's not as pronounced of a slope. So the intensity forecasts have gotten better with time, but at not nearly the same rate as the forecast tracks have improved. So it's been a big focus of research for a number of years now, and it's still a struggle. We've seen that this year already with a couple of storms. It's still the hardest part when it comes to tropical weather forecast. Now, we all saw an example of tropical forecast gone bad last summer, right, with Barry. So I thought this is a cool image. We're getting more and more of these the last couple of years with the astronauts aboard the International Space Station. So this is when Barry was still kind of organizing out here in the north and northeastern Gulf, Louisiana up in there, but still a cool shot as it was beginning to organize. We all remember this, right? So here's a rain forecast just 36 hours before Barry made landfall. In the purple, magenta shades, whatever you want to call it, 15 to 20 to 25 inches of rain was forecast in our local area. About a day and even as close to a day and a half before landfall. So we had everybody 3 years after the epic flood of 2016 thinking, uh-oh, here we go again. And there were river forecasts came out, said it could rival that. And then this happened. So here's the center of Barry at this point is just inland into Vermilion Parish, and the rain is struggling to move inland. This was something I posted to Twitter on that day, but it was almost like this magical wall here along the coast where you got the yellows, the oranges, the reds, the somewhat heavier rains. As they tried to move north and inland, they weakened. And just so that heavy rain never really materialized on the day of landfall here. It was just remarkable to see. Even the day of landfall is another thing I posted to Twitter, but this was just unlike anything I had ever seen. You've got 4 different forecast models. If we focus on Baton Rouge, this one said 1.9 inches of rain. This one said 1.5 inches of rain. This one said about 8 inches of rain. And this one still said 18 inches of rain. So even as the storm was making landfall, we had 4 models showing a range of anywhere from 1.5 inches of rain to 1.5 feet of rain in Baton Rouge. It was just an illustration of how crazy it was. All right, so after the fact, Dr. Marshall Shepard, he's the former president of the American Meteorological Society's professor at the University of Georgia, well-respected in the meteorological community. He posts this, it was almost like trumpeting the forecast. Boy, we did good with this. Because the other thing, if you may remember about Barry was kind of unusual. It originated from basically a little disturbance up over Missouri. It wasn't our typical system we track coming across the Atlantic. We were watching something up around Missouri and saying, okay, look out. This little disturbance we think is going to move into the Gulf of Mexico and could become tropical. So in that sense, it was a good forecast. But I quickly replied to him. I said, I don't think we should be celebrating the forecast if we miss so badly on the impacts. For instance, I pointed out how we had these forecasts. I think I was referencing the Comeet River. The Comeet River was forecast to hit a record level for Barry, even surpassing 2016. And then the next day, they lowered the forecast for the river by 25 feet. Just crazy change. So at times, I try to caution my colleagues to be careful what we're celebrating. Another kind of not so great forecast last year, I'm not sure how many of you will remember this one, was a storm called Olga. And by the time it came into Louisiana, the Hurricane Center said, we don't even think it's tropical anymore. And they call it post-tropical. This is a radar loop. As it came ashore, it was early on a Saturday morning, I believe it was. But you can see still well-developed circulation, heavy band on its eastern side. Didn't hit as hard in Baton Rouge, but as I'll show you here in a second, New Orleans up to the North Shore sure did get hit. So these are wind gusts that came from Olga. You got some 50s and 60s in the New Orleans area, 73 mile per hour gust up in Mandeville. So there ended up being some pretty significant wind damage from a storm that was considered no longer tropical as it made landfall. And where I got a little upset about it was I had posed the question the day before landfall to the Weather Service. I said, if you guys remember, you remember Superstorm Sandy, as it's called, that hit the Northeast in 2012. There's a lot of controversy with Sandy. Sandy was a storm that was also undergoing this transition from a hurricane into a non-tropical system. And since it was doing that, there were no hurricane watches, warnings, or anything like that up in the Northeast. And after the fact, a lot of people said they felt like that was a big reason people in the Northeast didn't take it serious enough, was there were no tropical warnings. So after Sandy, the Hurricane Center changed their policy. They said, even if a system is forecast to be non-tropical by landfall, if it's tropical as it approaches, we're going to post those tropical watches and warnings. Well, with Olga, we never did post the tropical storm watch or warning. And I'd even asked about the day before and didn't really get a good answer. So as it turned out, we ended up with tropical storm impacts with not much, with no warning posted. And then I heard people saying, well, there was no indication that was going to happen. And that's when I responded with some computer models. So these are forecast wind gusts. This is the morning before Olga made landfall. This is the European model. And if you can read, these numbers are tiny, but it was forecasting wind gusts in the 50s and 60s, right up into southeast Louisiana. Here's another model, the NAM, some wind gusts up into the 50s, tropical storm force winds. And I had posted another on Twitter showing tropical storm force winds coming ashore. So before I get to Katrina, that's just another thing that's frustrated me a little bit, that I felt like we could have handled better. I was supposed to give a presentation on Olga at the National Hurricane Conference that was supposed to be in New Orleans back in May, and obviously COVID happened, and here we are. So the last thing I'm going to show you before I wrap up, I just did want to talk about Katrina. Such a memorable hurricane, and one that I covered as a meteorologist as it approached and as it hit. And then I actually briefly kind of became a reporter. I was down in New Orleans for 4 or 5 days covering the aftermath. So I just wanted to show you a few pictures. So as you all remember, I'm sure, a big part of the flooding in New Orleans were levee breaches and flood wall breaches and breaks. Well, it hit home for me on especially the 17th Street Canal levee breach. So this is an aerial image on the left side that was taken before Katrina. Here's one that's taken after, and you see all the water that's spilled in where the flood wall is broken and the levee is breached. So this is Lakeview in New Orleans. And then on the other side here is Jefferson Parish. Well, why this hit home for me so much, if you see where I've got my mouse pointed, a block off of the 17th Street Canal, that's the parking lot for my elementary school, where I went to school from kindergarten right through 7th grade, right in here. So it's an area that I knew very well. So when I got sent down there to report, that's one of the first places we went. And so you can see, in fact, when I was a kid, you see the levee here. When I was a kid, the flood wall wasn't even here. They added the flood wall, oh, I don't know, maybe when I was a teenager, but it used to just be the earthen levee. Well, you see where the flood wall and the levee is completely breached over here and let the water in on the Lakeview side. Now, note the date. So Katrina made landfall on August 29th. Katrina was a Monday morning. I think this was the Saturday after. And there's the view into Lakeview. There's a bridge that goes right over the 17th Street Canal. And that was, 5 days after. You still had rooftop water. We eventually, a few days later, made our way to the Superdome. It was maybe a couple of feet deep, but still water there. There's water looking the other way down Poydras Street from the Superdome. We did make our way. We actually drove our news truck up those ramps up to the Superdome. By that time, all the people had been evacuated, and there were just National Guard there guarding it, but they would not let us in to see what it looked like. And then this is another quick story. In the summer of 2005, I had interviewed a man in St. Bernard Parish who had gone through Hurricane Betsy in 1965, and his father died in Betsy. And so I'd interviewed him in the summer of 2005 before Katrina to tell that story. Well, after Katrina hit, I don't remember exactly when, he calls us up at some point and says, hey, do you guys still have the video you shot in my house? He said, that may be the last time I get to see some of the pictures we had on the wall. So he got to go back. It was exactly a month later was when he was allowed back in to see his house, September 29th. We went back with him. So here's an instance where this isn't his house, but a house that as the floodwaters came in, the whole house floated and then landed on the street. And there was a lot of this. The cars floated up with the floodwaters, came down. This one landed on a fence. This belonged to the guy who we actually interviewed. We went to his house. That's his car. And that's what the inside of his house looked like. It was devastating. So right here, this wall, you can still see a couple of the pictures hanging, but he probably had 30 pictures on that wall, I bet. And that's where at least we still had that video and were able to give it to him. The only thing he salvaged were a few boxes in his attic, but the house was a complete loss. Just another picture from the neighborhood. And then, as I mentioned, I grew up in Metairie. So it was a whole different issue. I don't know how many remember this. Jefferson Parish and Metairie, most of the flooding was not from levee breaches and flood wall breaches. It's because the pumps weren't running. New Orleans, Jefferson Parish, all that area, the water's got to be pumped out. Well, Jefferson Parish had a real failure of planning. They had not figured out what to do with the pump operators in the instance of a major hurricane like Katrina that coming this way. So as Katrina approached, they evacuated the pump operators for safety reasons, but they had no way to operate the pumps. And so when it started raining, none of that water was being pumped out. And so this is the house I grew up in. My dad was still living in that. He had evacuated, but he was still living here. We had one neighbor across the street. She stayed. She took this picture the day of. And I think in Jefferson Parish maybe ended up with maybe like 7 inches of rain. It's not the kind of rain that would have produced this, but it was the fact there was a failure of planning and no pumps running. They've since figured it out post-Katrina. They've built safe houses, and hopefully that'll never happen again. But frustrating for all the Jefferson Parish residents that flooded because it was preventable. All right, so as a wrap up, a little cartoon for you. Summer in Louisiana. Well, we live in Connecticut, but we summer in the Hamptons. And then these guys say we live in Louisiana and we summer at a Motel 6 in Houston. Maybe better to summer at a hotel farther north if you're going to evacuate. But that's all I've got. So with that, I will welcome any questions you guys may have.
All right, thank you very much. I've muted everybody's microphone during the presentation, so if you have any questions, you can go ahead and unmute yourself. Just hover over the bottom, hover to the bottom of the screen and highlight the microphone that should be crossed out, and you'll be heard, hopefully.
I don't have a question. I've got an observation of something I saw in Merrow when we went down to salvage what we could from my aunt's house. We saw a brick house on a poured concrete slab that had lifted and floated in the middle of the highway, which I
Wow.
never believed unless I saw it with my own eyes.
So then you wonder, was the anchoring done right and what happened there? But it's remarkable no matter how it happened, right?
Yeah, I went through Hurricane Betsy. We had 7 feet of water at our house in 1965.
Yeah, this gentleman was in Araby that we interviewed.
That's where I lived. I lived in Araby in Carolyn Park.
Yeah, I remembered the name of his street for the longest time, but I can't remember it now. But my wife's from Chalmette, so we know the area.
I wanted to ask if it was all right. My name's Thomas. When I was many years ago now in college and I took a geography course, I remember my professor said that he referred to it as not the Coriolis force, but the Coriolis effect, simply because the fact that the Earth rotates on its axis, or at least the effect of that isn't, at least if I remember him correctly, isn't necessarily a force. Would it be possible to talk about why there's a difference between the terms and which is the more accurate one, I suppose, to use, if that's possible?
You get a little dirty in the details there, but I think it's more of it's a perceived shift in direction because of that rotation. I'm not going to do a great job of explaining it, but I think the physicists would tell you it's not a real force, kind of like what you're describing. It's a perceived deflection because of that rotation. But in the end, it's ultimately what leads to our spinning systems. Now, the one thing I didn't talk about, the most common misconception, or sometimes the goofiest thing you'll hear is, oh, if you flush a toilet in the northern hemisphere, it's going to spin counterclockwise, but if you go south of the equator, it'll spin clockwise. That's not true. A toilet is too small for the Coriolis force to act on it. So if you ever hear that, don't believe it.
Gotcha.
One other thing I did want to mention, you guys, real quick, talking about Betsy that I forgot to mention. So I showed you all the forecast numbers for a very active season. One thing that's an important point that I did not mention is we know a very busy season does not always correlate with a lot of landfalls. There have been very busy seasons where most of the storms stayed out over the ocean. And conversely, years like 1965 with Betsy, 1992 with Andrew, those were seasons that were overall quiet, but that old adage, if it only takes one, well, we got the one here in Louisiana those years, quiet years that had big impacts. So while we warn you with these big numbers forecasts this year, they still don't really tell us much about where they're going to end up.
Yeah, the Andrew would have been the A storm. So yeah, that's the first one. That's about like getting hit by a stray bullet when you're at a New Year's Eve party or something like that.
Right. Yeah, you think about Andrew, it was the end of August, and like you say, the A storm. So that's why it's cliche, but it's why we repeat that it only takes one, because there's plenty of examples of it.
But I remember Andrew was actually my first major hurricane. I remember growing up with stories of Camille and Betsy from the grand folks, and so I was waiting for my big storm, and I thought Andrew was the big storm. But of course, I was in Louisiana at the time. I remember going and went up with summer camp, and it turns out I was giving a big wind-up pitch about how I suffered through the horrors of Andrew and everything like that. And it turns out one of the guys that was also in my class was in the Florida part where they got hit by Andrew.
Yeah.
And so I was talking about how I was out without power for a couple of weeks, and he was talking about how he watched a 2x4 go through the telephone pole of his neighbor's house.
Yeah, the interesting thing about Andrew in Florida was initially it was live was called a Category 4, And it took 10 years. 10 years later, they got the upgrade to Category 5, which is, they do these post-storm analysis all the time. In fact, Betsy just last year, they upgraded it to a Category 4 in Louisiana. But Andrew, another memorable thing in South Florida is the National Hurricane Center went right through the eye of it. At the time, they had a radar on the roof, and they sent out a message at one point in the height of the storm that the radar just got blown off our roof. I mean, it was crazy.
There was I remember watching that entire swath, and it looked like somebody just took a bulldozer through Florida there.
My first memory of a hurricane was I grew up in Houston, and my first memory is of Hurricane Carla.
Yeah.
Mm-hmm.
I remember that one coming through, and a news person on the CBS station in Houston went down to Galveston and sat in the CBS news station in Galveston and did live pictures of Carla for the whole storm. That person's name was Dan Rather.
Yeah, that's famously, I think, where he strapped himself to a telephone pole, as I remember, right?
Yeah, that's how he made his name, and that's how he managed to get up to network.
Yeah.
Now, the interesting thing is, you know who he replaced when the person he originally replaced went to network? You know who that person he replaced there in Houston?
I don't.
A gentleman by the name of Walter Cronkite.
Oh, yeah.
He's a local newscaster in Houston, and when he finally got to go to network, Dan Rather was the one that took his place in Houston.
That's remarkable.
Yeah, but I remember Carla. I remember our backyard, a couple foot of water in it. I remember the eye passed over my house. We were in the eye of it.
Wow. Yeah.
But I thought it was really interesting to see that the predictions are becoming more accurate over time, because it seems if you talk to the old folk, especially, they always seem to argue that weather forecasting is not what it was 10 years ago. But it seems to me, the thing that I keep hearing from the weather folk is that it is consistently getting better, and that the predictions now for 5 days out is what 3 days out was 30 years ago or something like that.
Yeah, it's the battle I have to fight daily. And I tell people it's not about me, it's not about any particular meteorologist, but the science, without question, has gotten better. In fact, I think it was back in the spring, right before COVID, I gave a whole presentation on that very topic, how weather forecasts have gotten better with time. And there's indisputable evidence, but it's, there's perception and reality. It gets muddy. And the other thing is sometimes people there's a nostalgia factor. People have a favorite weather person they grew up with, and it's hard to, beat that person that they grew up with. But yeah, it's sometimes the most frustrating part. If I tell you how many times somebody walked up to me and said, "Oh, I wish I could get paid to be wrong 50% of the time," and then they always think they're the first one that have told you that joke too, But if you do this, you better have a thick skin to do this business. So I've been at it for 20 some odd years, so it doesn't rattle me much anymore.
Well, it's 20 years. I guess you've been getting steadily better at your job over time too. So
I hope I've gotten. I can tell I was pretty bad when I started, so I hope I'm a little better.
I have a weather question for you.
Sure.
How many models do you use for hurricane prediction?
That's a good question. So typically, there's two. We have what we call mesoscale and regional models, basically, and then we have global models that actually forecast weather for the entire globe. When we look at the global models, which we often lean on most heavily for tropical systems, there's two main ones. There's the European model, and there's the GFS, the Global Forecast System. It's what some people now call the American model. But there are some other models. There's a couple other global models that are coming more into play and are improving with time. The Germans have one called ICON. The Canadian model, which used to kind of be the butt of a lot of jokes in the weather community, has gotten a lot better. We look at all that. We look at a whole suite of them. But what you really look for is you're trying to find consensus. And if you see a lot of divergence, then you say, uh-oh, this can be a tough forecast. One thing, I didn't know how many of you may have seen us talk about this, but one pretty neat development in weather last 10, 15 years is this ensemble approach to modeling. So if we take the one that so many people know, that European model, they run the main model, and now they run 50 variants of it where they just tweak the initial conditions slightly. And what that does is it better accounts for uncertainty, and it gives us a better range of possibilities. And so if we take a look at that ensemble guidance for a tropical system, it'll literally give us a map with 51 lines. And so if you see the lines clustered pretty good, then you know the forecast confidence is pretty good. If you see a lot of spread in those lines and those tracks, then you know there's probably at least 2, maybe 3 viable scenarios, depending on some subtle changes in the atmosphere.
Well, I was asking because I heard that last year, I read somewhere that there was something like 18 different models that have been used by people. And I also read something last year that the one that's the most accurate last year was one that came out of Russia.
I'm not sure I saw that one. I'm not doubting you, but generally speaking, for the one that people know, the European as a whole has performed best in recent years. But where we have to caution people when they go online, start looking this stuff, is it doesn't mean go look at the European every storm, because the GFS still has victories. Other models still have victories. Even ones that overall, they do get scored at the end of every hurricane season. Sometimes even the ones that end up with a poor score at the end of the season, every what's the saying, a blind squirrel still going to catch a nut every once in a while. Even those ones that perform poorly, they sometimes hit on a particular storm. Right. So it's where I tell people, it's kind of like being a chef in the kitchen. We take the models, we do some analysis on our own by looking at satellite and some other products, and then we toss in a little bit of our experience too. And that's really how the forecast comes together.
Right.
Yeah, and I seem to remember that there was talk of revising the preferred model for the Americas either last year or the year before. But I guess y'all are constantly revising the way y'all are doing y'all's algorithms, which makes sense. I especially like this idea of it had never occurred to me that y'all were varying the start conditions before y'all ran y'all's models in order to get a better cone of probability. And I think that's fascinating.
Yeah, when I was going through my undergrad days in the 90s, I don't remember hearing much about the ensemble forecast techniques. Like I said, it's been more like the last 10, 15 years where it's really taken off. But even now, in forecasting day-to-day temperatures, we're using the similar techniques a lot more. The National Weather Service has now developed something they call the National Blend of Models. And in essence, they're taking its input from hundreds of sources. And I'm oversimplifying it a little bit, but it's almost like averaging, these hundreds of models and then giving you an N number forecast. And in the end, it works out pretty well.
It's absolutely fascinating. It's ultimately at the end of the day, it's still predicting the future. It's just, it's well-reasoned predictions of the future.
Right. Yeah. There's always an element of chaos in the atmosphere, the butterfly effect.
Yeah.
One small change upstream can all of a sudden have big consequences downstream if you don't pick up on that small change upstream. And one of the things I tell people all the time, one of the biggest limitations in our forecasts, there's really 6 mathematical equations that really sum up most of the motion of the fluids in the atmosphere and how weather works. And all the computer models, they use that. That's the basis of it. And we've had those for a long time. One of the limitations still is just not having enough current observations. Yeah. There's still data gaps. For instance, a bit of a blind spot for our part of the world can be if we've got something, I'm not talking tropical, but we can get non-tropical systems that are coming from northern Mexico and head up this way and produce rain. We launch a lot of weather balloons here in the United States. They don't have a very good network of those in Mexico. So sometimes little subtle disturbances in the atmosphere go essentially undetected. Those don't get into the models. And then, that's how a forecast can kind of blow up in a hurry.
Yeah, so it's kind of like when you're trying to figure out re-insulate your house, and if somebody just doesn't check certain rooms, you have no idea where the heat is flowing out of that.
Right. Exactly.
Makes sense to me. Which is that the idea then would be just to try and get rid of those gaps over time, which I think so far the emphasis has been on satellites, and I tend to neglect the weather balloons because we're all space geeks here, so if it's not in orbit, it doesn't really stick in my mind.
Well, the other thing that's really helped in recent years, and every year that goes by, they're adding more and more, but aircraft. We're now getting a lot of observations from aircraft. And IBM's been pretty heavily involved in that on their own. They've contracted. IBM recently came out with their own weather model. And a lot of that is a lot of their input comes from aircraft that they've supplied the weather equipment. They go on the aircraft, they get the data, but it definitely over the oceans, huge data gaps. And so they try to fill that with what you mentioned, satellite, and with aircraft.
That's great.
I have a question. Kind of forgive me if you mentioned this earlier on. I was about 10 minutes late. Sorry. But a practical question for amateur astronomers here. Just talking about, I know I've heard in the past that when we see in a forecast that, there's a 35% cloud chance or rain chance or whatnot, that or say 50%, that it doesn't mean like, it's a 50-50 chance that there's going to be rain. It's more to do with the coverage area or something, or how much of the coverage area is going to see rain. So could you explain that maybe a little bit?
Yeah, and unfortunately, it's a real inconsistency in the world of weather. So it can be either or, depending on who you're talking to. Generally, in the world of television, we use it as a coverage to represent coverage. So when we say 50% chance, we're essentially saying we expect about half of our viewing area to get rain. But in fact, you can pull up model forecasts, point-specific forecasts, and those are really representing a probability specific to whatever point you're pulling up. That makes sense?
Yeah.
It gets discussed constantly in the weather community, and because A, it's inconsistent, and B, even when explained, a lot of people still struggle to even understand it. So it's a real problem. It is.
Is there any way of knowing, like what you're looking at? If I go to a certain site, is there any way of knowing, okay, they are telling me this as a probability versus the coverage thing? Is there anything?
The National Weather Service is more going to be point specific than what we do on TV typically. So if you go look at their site. Now, one thing I'll try to do when we can, some days the rain coverage, in fact, most of the summer, for instance, the rain coverage is going to be pretty random. But there are some days where there's pretty clear signal where it might be obvious that there are going to be better rain chances along the coast and lower rain chances the farther inland you get. We'll try to point that out when it's obvious. But no, unfortunately for the end user, a lot of times it's not the easiest thing to figure out.
Yeah. Thank you.
Sure.
Okay. Any other questions?
Hey, Steve. Yeah, I just wanted to thank him for being on. I know I got here late. I was unpredictable whether or not I was actually going to be on the call tonight, given my situation. But
Well, no,
Steve, I thank you for coming on and talking with us. One of the things I think, well, two of the things I appreciate about this subject is probably near and dear to all of our hearts, especially in this area, right? And you could hear that in all the questions that you got. But the other point for us doing outreach is that I love that when we can understand what happens on our own world, we can possibly better understand what happens on other worlds and make sense of it to the general public. And having informative presentations by people like yourself allows us the opportunity to get that information and maybe articulate it in a better way. So I really do appreciate what you've done.
oh, absolutely. Thanks for inviting me. And a side note, I hope you're able to get everything resolved on your end. I'm sorry you've been going through all that.
Yeah, we're staying in a temporary room and got a repair guy supposed to be on Wednesday, but yeah, it felt more just kept coming down. A guy stepped on one of the fire spigots upstairs above us, and that just gushed, and that just set it all off. So
It's like every day you hate to see what 2020 is going to deliver next, right?
It's also nice to see a flooding forecast that wasn't your fault at all. So, we'll close it on that, perhaps, for you.
My wife joked that, we were worried about flooding, when the storms came through, and we're like, well, we're on the third floor, and here we're on the third floor, and we get extra water damage.
Oh, man.
But if there aren't any more questions for Dr. Caparptta, we'll let him go. And I'm guessing it's about time for children to go to sleep. And since he did steal his daughter's room, I'm sure they're going to need it back. So we can't hold him for very much longer.
I'm in their playroom, but yeah, their mom's probably getting them in bed right now. So I do need to go tell them good night.
Yeah, so we're going to go ahead and let you go your way. And thank you again very much for coming and speaking with us today. It's been a most informative and entertaining talk tonight.
My pleasure. Thanks for inviting
thank
me.
you.
Thank you.
Thank you.
All right, so good night. And I'm going to go ahead and with that, I will cancel our live stream and for the our people over on YouTube. And just give me a second here. Some of this takes a little bit of time to